Today's topic is absolute value inequalities. And when we talk about absolute value inequalities, we are talking about, for instance, the absolute value of x is less than 3. These are the points that are going to be less than 3 units from 0. So for example, if you should look at this, these are going to be the ones that result in the conjunction or the and statement. In this case, if we graph things that are less than 3 units from 0, you get a situation like this, where you have the negative 3 is less than x is less than 3, the conjunction, and I like to remember that these are our and statements. Now on the other hand, if you have the solutions to the absolute value of x is greater than 3, these are going to be those points that are more than 3 units from 0. So if we graph that, we graph on opposite sides of negative 3 and 3, which ends up creating a situation that has x is greater than negative 3, or less than negative 3, or greater than 3. And it would graph on the outside. These are our disjunctions. Or our or statements. So these are a good thing to try and remember, because if we can remember that if it's less than, it's going to be that and statement, and if it's greater than, it's going to be our or statement. I like to think about it this way, in that we would, in one of these situations, have that if it is the absolute value of x is greater than a, we're going to keep the first one as it is, greater than a, and then we're going to change, we're going to have the and we'll have x is less than and negative a, we're going to change that other way. So I like to think of it as keep, change, change. Keep, change, change. So then it's kind of like it was keep, change, flip with dividing fractions. Now on the other hand, if we have the absolute value of x is less than a, it's going to be that same situation though of keep, but it's going to be an or, change, so it'd be x is greater than negative a. So think about that as we go through our examples here. Our first example we have the absolute value of 5 minus 3x is less than 9. So if you remember back to what we were just talking about, this is going to be one of our and statements because of our less than sign here. So we know it's going to be and. So we keep the first one, 5 minus 3x is less than 9, and 5 minus 3x is greater than, so we change it, and the second change, negative 9. And then once we do that, we go about solving these the same as we always would, but solving them separately. So first we're going to subtract 5 from both sides, and we get negative 3x is less than 4. Then we divide both sides by negative 3, which means, remember, we flip the sign because we're dividing by a negative, and we get negative 4/3. Going over to the other one, same thing, we're going to subtract 5 from both sides, which will give us negative 3x is greater than negative 14. And then when we divide by negative 3, we flip the sign to get x is less than positive 14/3. Now, if we think about these, negative 4/3 is approximately equal to negative 1 1/3 or negative 1.3. And 14/3 is approximately equal to 4.7. So if we go ahead to graph these, I'm going to go about making this negative 2, 0, 2, 4, 6. So both of these are strictly less than, strictly greater than. So we're going to have negative 1 1/3, which will be about right here, and positive 4.7, which is about right here. And I see that we have x less than, x greater than negative 4/3, which would shade this way. And we have x less than 14/3, which goes this way. And because it is this and, we are going to end up shading in between because we know it's an and statement. Looking at this next one, let's go ahead and take a look at this, and we see here, as I change back to a pen, that I have the absolute value of 3x minus 7 is greater than 1. So I know that this is going to be an or statement, and I'm going to keep change. So I have 3x minus 7 is greater than 1. We'll keep that the same. Or 3x minus 7 is less than, there's one change, negative 1. There's the second change. So now if we go about solving this, first I add 7 to both sides and I get 3x is greater than 8. Divide both sides by 3 and I get x is greater than 8/3. Likewise, if I take and add 7 to both sides, I get 3x is less than 6. Divide both sides by 2 and I get x is less than 2. So thinking about this, I see that 8/3 is 2 2/3, so this is approximately equal to 2.7, give or take. So I'm going to do 0, 1, 2, 3, 4, and 2.7. We'll do a circle, open circle there, and an open circle at 2. And then I see that we're less than 2, but we're bigger than 2 2/3. So we're going to shade on the outsides there because it is a disjunction. Let's look at the next example. This one is a little bit more complicated. I will give you a hint here. The hint is that we really should divide by 2 first. Because if we don't divide by 2, we won't have that inequality by, or the absolute value by itself, which is what we need. So if we divide by 2 first, we end up with the inequality of the absolute value of x plus 10 greater than or equal to 4.5 or 9/2. So because this is greater than, this is going to be an or statement, which states that x plus 10 is greater than or equal to 4.5, which is our keep statement, or x plus 10 is less than or equal to negative 4.5. Then we can go ahead and solve these individually and graph them. Please feel free to go ahead and do so, and we can check those with us as a class tomorrow. And then finally, our last one here, This one is kind of tricky. It's one you have to really be careful. The thing that's hanging us up here is this right here. If you recall back to our first thing here, we had said specifically that x has to be, one of the things we didn't talk about per se is that x must be positive. If it is not positive, these won't work, because remember, when we have an inequality, or sorry, an absolute value is always positive. So because this is negative, this is impossible to do, so this is going to be no solution. So now your job is going to be to complete these two problems and bring them with you to class tomorrow.